We're diving into a massive, and I mean absolutely massive, leap in technology that IBM has just announced. We talk all the time about tech moving fast, but every once in a while, a breakthrough comes along that fundamentally rewrites the rules of what's physically possible. IBM has just unveiled the world's first sub-1 nanometer chip technology. This is a game changer that's going to completely supercharge artificial intelligence, cloud computing, and honestly, the future of pretty much every electronic device you own. Just take a look at that number right there. 100 billion. Now do me a favor, hold up your hand for a second and look at your fingernail. How could you possibly fit 100 billion of anything onto a space the exact size of that fingernail? It sounds like straight up science fiction, doesn't it? But as we're about to see, it is now science fact. So let's dive into exactly how IBM pulled this off. All right, section 1. The 100 billion transistor chip. To really wrap our heads around the scale of this breakthrough, let's just quickly ground ourselves. What is a transistor? Basically, it's just a tiny switch that processes information inside a computer chip. The golden rule of computing has always been pretty simple. Add more of these microscopic switches, and you got a drastically more powerful device. But finding the room to pack them all in, that's the ultimate challenge. So let's put this new density into perspective. Just 5 years ago, back in 2021, IBM made massive headlines with their 2-nanometer chip. That was a huge deal at the time, packing roughly 50 billion transistors. Fast forward to today, 2026, and this new sub-1 nanometer chip crams nearly 100 billion transistors into that exact same fingernail-sized space. They have literally doubled the processing power in just half a decade. But, getting here wasn't just a matter of doing the same old thing they've always done. Which brings us to section 2, the problem with shrinking. The reality is, chip makers are quite literally running out of horizontal space to shrink individual components using today's manufacturing methods. Think of a computer chip like a really bustling, crowded city. For decades, the strategy has just been building smaller houses and shoving them closer together on the ground. But eventually, you just run out of land. We absolutely cannot shrink these individual components much further on a 2D plane without breaking the laws of physics. Now, what's really interesting about this next slide is how they solve that. Section 3, the vertical nanostack solution. Well, if you can't build out, what do? You build up. Enter the nanostack. This is a 3-dimensional chip architecture that stacks transistors vertically instead of side by side. Going back to our city analogy, IBM essentially stopped trying to build tiny houses and started building skyscrapers. By stacking these microscopic parts vertically, they can fit a dramatically larger amount of computing power into the exact same horizontal footprint. It's brilliant. Jay Gambetta, the director of IBM Research, really hit the nail on the head here. He noted that IBM's latest breakthrough pushes technology beyond the nanometer era straight to the scale of atoms. With this new nanostack architecture, they aren't just making smaller transistors, they're completely reinventing how chips are built. And that scale is exactly what I want to emphasize here. We aren't even talking about nanometers anymore, we are engineering at the atomic level. They've entirely reinvented the architecture of modern computing, and honestly, the timing couldn't be better. Let's move to section 4, powering the AI era. So why does an atomic scale breakthrough actually matter to us right now? Well, it's all about the exploding demands of artificial intelligence and cloud computing. Check out this incredible either-or choice IBM's new tech offers compared to those 2021 chips. You can either choose 50% better performance, which means supercharging AI data centers and making our future phones blazing fast, or look at that second bar, 70% less power consumption. Try to imagine the massive electricity costs saved globally if these giant data centers suddenly need 70% less power to do the exact same amount of work. It is an absolute win for both performance and energy efficiency. But wait, there's even more efficiency to unpack here. Research recently presented at the VLSI 2026 conference showed this nanostack design also shrinks the chip's built-in memory, called SRAM, by a solid 40%. Actually, scratch that. It doesn't just shrink it. By freeing up that crucial 40% of real estate on the chip, IBM leaves even more room for dedicated processing power. And that's exactly what we need to meet the heavy growing demands of modern AI apps. Of course, building a chip at the scale of atoms doesn't just happen overnight in a vacuum. And this brilliantly illustrates our final point, section 5, the future of computing. To bring this incredibly complex technology to life, IBM relies on a coalition of heavy-hitting global partners. We're talking about companies like Lam Research, Tokyo Electron, Screen Semiconductor Solutions, and ASML, all collaborating out of IBM's research facility in Albany, New York. It takes a massive, coordinated, industry-wide effort to push computing past the nanometer era.
So the big question, when can we expect this to actually be in our pockets? Let's walk through the timeline. We saw the 2-nanometer milestone in 2021. Today, in 2026, the sub-1 nanometer nanostack was just revealed. And projecting forward, IBM expects this technology to be ready for commercial rollout within the next 5 years, so around 2031. A whole new generation of smaller, faster, and wildly more energy-efficient computer chips is literally just on the horizon.
Which leaves us with a final, pretty wild thought to chew on. As we transition from measuring our technology in nanometers to measuring it in literal atoms, how will a fingernail-sized chip holding 100 billion vertical transistors transform the devices in your hands? The possibilities for AI, for our phones, and for cloud computing are genuinely limitless.